Alright, this is a quick tutorial about how to find the standard error of the mean and the standard deviation for a set of data. So this is going to help us figure out our standard error of the mean as we analyze our sex in the single guppy lab. So this set of data I have right here is looking at the first generation of my brightest fish. I started with an even mix over every color, so in trial 1 I had 23%, trial 2 25%, 13% brightest in trial 3, and 28% brightest in trial 4, with a mean of 22. It's 22.5, but I like to round with numbers this big. So to find standard error of the mean, we have to think about what the equation is for that. And so standard error of the mean, standard error, and we use that for mean, x bar, right, equals s, which is the standard deviation, over the square root of n. And n is the number of groups that we're looking at. So, but first we have to figure out standard deviation. Alright, and so the equation for that is standard deviation is the square root of the sum of x, which is any one data point, minus the mean x bar squared, divided by n minus 1. Alright, and n is our number of groups, or in our case, our number of trials. So what we know, right, is that we know that x bar equals 22, and we know that n equals 1, 2, 3, 4. N equals 4. Okay, so in order to find the standard deviation, let's just start finding all of these so that we can add them up. Alright, so for this trial, all our x's, let me set this up. Alright, so we do 23, because that's this first data point, minus the mean is 22 squared, and then the next one is 25 from trial 2, minus the mean, 22 squared, 13 minus 22 squared, and 28 from trial 4, minus 22 squared. Alright, so we can solve those quickly. Now, 23 minus 22 is 1, and 1 squared is 1. So we don't even need our calculator for that. Alright, similarly, 25 minus 22 is 3, and 3 squared is 9. Of course, you can use your calculator for all of these things, but I hope some of these simpler ones you can do in your head. Okay, for this one, 13 minus 22, right, is negative 9. Negative 9 squared, 81, right? And so we'll write that. And then 28 minus 22 is 6. 6 squared is 36. Alright, now let's add all those up, because we need to take the sum of all of those. Okay, so we can use a calculator, or 9, 10, 11, and 6 is 17. Carry the 1, 8, 9, 10, 11, 12. 127 is this value right here. So to find our standard deviation for this set of data, just going to do this, right? S equals the square root of 127, that was this value that we found right here, 127 divided by n minus 1. And n, as we said before, equals 4. So n minus 1 is 3. Now we use our calculator for 127 divided by 3 equals, I'll round to 42. S equals the square root of 42. So standard deviation equals square root of 42. 6.5. 6.48. I'll round to 6.5. Awesome. Okay, so now we can use this standard deviation to help us find standard error of the mean by plugging it in here. So if standard error of the mean is the standard deviation divided by the square root of n, then we use 6.5 divided by the square root of n, which is still 4, right, equals 6.5 divided by 2, which equals 3.25. Again, if you can't do that in your head, you can do it on a calculator. And so here's our standard error of the mean, and this is important because when we go to draw a graph and we have our drabbest section and we are looking at our percent of drabbest guppies, then our value will be, 22 is our mean. And then since we're just going to use one standard error of the mean, you can use 2 as long as it's standard, right? It'll be plus or minus this right here. So we'll make our I bar the distance using 3.25 below or above the mean. And that's how you find standard deviation, apply it to find standard error of the mean, and use it to help you draw an accurate graph.